I want you in the notes portion. We are going to talk about amplitude. Amplitude on a sinusoidal graph is half the vertical distance. LE, would be LE. Or ventricle. Or ventricle. E. Or any other thing other than vertical. Here we are. I'm like, something is wrong. Okay. Which I write vertical 8,000 times correctly in vertical stretch in Math 30-1. Don't know why I just slumped on that one. It's because the phone and then phony and then, food all have fuzz. But we got some PHs in there. It's a mess. Whatever.
I will never spell it the same thing.
Anytime.
Anytime. Never.
And then the American-Canadian splits on all the things, like color.
I hate when you're typing on Google Docs and then I'll spell it with a U most often. It's like, that's wrong. No, it's not.
No, it's not. Stop.
Yeah.
Half the vertical distance. Between the max and min. The other thing about it, it is always positive. Very important. So if ever they ask you for the amplitude and give a negative answer, you won't pick it. It's always positive. And then your amplitude. There is a formula, and this is what you use if it is a graph. So if you're given a graph, the amplitude equals the absolute value of the max minus the min divided by 2. And why do I have absolute value signs? Because absolute value signs turn anything negative positive. And the amplitude has to be positive because it is a distance, and distance can't be negative, right? Displacement maybe, but distance cannot. So your amplitude is max minus min divided by 2 with the absolute value sign, because if you got like absolute value of -2, how far is -2 from 0? 2. So the absolute value signs actually are the distance from 0. So -4 is 4 from 0. -8 is 8 from 0. So that's why it always turns out positive. Okay? All right. So we're going to go back and we're going to do the amplitude of all of these. So we're on the very first page. So we're going to figure out the amplitude. So the amplitude is half of the vertical distance from the min to the max. So we can just calculate it. Okay? We can just calculate the amplitude by remembering that it's half the vertical distance. So what is my vertical distance from here to here? If I count it, it's 1, 2, 3, 4, 5, 6. It's a vertical distance of 6, correct? Yeah? And what's 6 divided by 2? 3. So the amplitude is 6 divided by 2, which equals 3. Or we can use the actual formula. Amplitude. And make sure you have room because we're going to put amplitude on here, period, and equations, and midline. So the amplitude is the absolute value of the maximum. What's the maximum on this one? 3 minus the minimum. What's the minimum? -3 divided by 2, which is 6 divided by 2, which is 3. Same answer, correct? So we can just use the formula as well, because 3 minus a minus 3 is 6. Okay? So, let's do the vertical distance again for this one. We'll practice both ways. Which one's better? The one that you choose. But you still have to show work either way. So, vertical distance. 1, 2, 3, 4, 5, 6, 7, 8 is my vertical distance. We agree? So what's my amplitude? 8 divided by what? 8 divided by what, guys? 2, because it's half the vertical distance, so it's 4. So we can do it that way, correct? Or we can use our formula. Amplitude equals the absolute value of the max. What's the maximum? 6 minus, what's the minimum? -2 divided by 2. What's 6 minus a minus 2? Plus. So it's 8 over 2, which is 4. So it's half that vertical distance from the min to the max. And 6 minus a minus 2 is actually 6 plus 2, which is 8 divided by 2. So it's half that vertical distance. Okay, for this one we need a little bit more information. So we have a maximum at 3, 6. Then they also have to tell us we have a minimum. That's a lie. At 3, 3, 3, 6. What? At 3, 3. And we have a minimum at 9 and -3. I want you to give me the amplitude. What's the vertical distance from -3 to 3? 6, right? -3, -2, -2, -1, -1 to 0, 0 to 1, 0 to 2, 0 to 3. So we know that our amplitude, bless you, is 6 divided by 2. If you can visualize it as half the vertical distance, which is 3. If you can't, and you're like, Mrs. Lepp, I really like formulas. Cool. Use a formula. Like, I don't care. The only catch is that it's not on your formula sheet, right? So you have to have it up here in your beam. Okay. So amplitude equals the absolute value of the max, which is 3, minus the min, which is -3, divided by 2. And what's 3 minus a minus 3? 6, because 3 minus a minus is actually a plus. So we get 6 divided by 2, which is 3. Same thing, right? All right, then we're going to flip over. We have 4, 5, 6, 7. And somehow I put an extra page in there. 8 and 9, I know it has equations on it. Don't really care about that. I want the amplitude for both of those as well. And 10 and 11. Go. Amplitude for all of them. Every single thing. So all the way from 4 to 10. Shouldn't take you long. So, amplitude equals the absolute value of what's the maximum here? 0.8. Minus what's the minimum? -0.8. Divide by 2. Minus equals plus. And you get 0.8. 5. Amplitude equals the absolute value of the maximum, which is 4, minus the minimum, which is -4. Divided by 2 is 8 over 2, which is 4. These ones are all symmetrical about the x-axis, right? Whenever they're symmetrical about the x-axis, the amplitude is just the vertical distance up or the vertical distance down, right? Number 2 wasn't symmetrical about the x-axis, so it wasn't the same. Okay, this one. Amplitude is the absolute value of the maximum, which is 5, minus the minimum, which is -5, divided by 2, which is 5. This one's 6 and -6. So the amplitude equals the absolute value of 6 minus -6 divided by 2, which is 6. I'm going to flip over. I somehow made myself an extra page. The amplitude for this one, is this one symmetrical about the x-axis? Is the same amount above as below the x-axis? That's what I mean by symmetrical. No, so it won't just be the vertical distance, right, from the x-axis up. So this one's going to be the absolute value of the maximum, which is 2, minus the minimum, which is 4, negative 4, sorry, divided by 2. So it's 6 divided by 2, which is 3. Do we agree? Okay. Then the amplitude for this one equals the maximum, which is 4, 5, 6, 7. Absolute value minus the minimum, which is 1, divided by 2, which is 3. We agree? Okay, then we're going to flip over. This one, the amplitude equals the maximum, which is 20, minus the minimum, which is 10, divided by 2. So it's going to be 10 divided by 2, which is 5. Now, there's a great way, or is there one more? Oops, yep, 11. So for this one, the amplitude equals the maximum, which is 5, 6, 7, 8, 9, minus the minimum, which is negative 3, divided by 2, which 9 minus 3 is 12, divided by 2, which is 6. Now, the way we can check our amplitude is if your amplitude is correct, if you count that many up from the minimum and down from the maximum, they should meet at the same spot, correct? If they're half the distance, do you know what I'm saying? So if I count from minimum up, maximum down, they should meet at the same line. So we're going to go back and do that for every single one we've done so far to double check it. Plus, it helps us get the midline, which is the next thing. All right. So we're going to use a different color. I'm going to use red. So my amplitude is 3. If my amplitude is correct, I should be able to count from maximum down and minimum up, and they should meet at the same spot, correct? So I count 3 down. 1, 2, 3. I count 3 up. 1, 2, 3. And they both meet here. Draw yourself a line here. It's the x-axis, which is the line y equals what? What is it? Y equals? What's the x-axis? The line y equals what? 0. And we know our amplitude's right because we met at the same line. Everyone should be drawing that line. That line really matters. So if you don't draw it now, you're going to have to draw it later. If you don't have highlighters to draw the line, I do. Grab them. It will be helpful if you grab a highlighter if you don't have one. All right. That's the line in the middle. I would highlight it if it were me and I were you. All right. Number 2, the amplitude is 4. So I should be able to count down 4 from the maximum, count up 4 from the minimum, and they should meet at the same line horizontally, correct? So let's count. We don't count this as 1, we count this as 0. So I need to count 4. 1, 2, 3, 4. And I'm reaching what looks like 2, correct? Now hopefully if I count the other way, I get to 2 as well. 1, 2, 3, 4. Now I have a horizontal line. What is this line at? Y equals what? 2. See what I'm saying? So I know I'm right. Because it's half the vertical distance, yes? From bottom up, top down. Okay, this one, I know I can keep going 7, 8, 9, and it's at negative 3. So I know I have a line down here, and the graph keeps going, correct? So I can keep sketching it for my own welfare. Okay, I'm going to count down 3 because that's the amplitude. So 1, 2, 3. And I'm going to count up 3. 1, 2, 3. They're the same distance, correct? Where are they meeting at? Yeah, the x-axis, which is the line y equals 0. You're right. Everyone should be drawing that. Okay, then we're flipping over. Now my amplitude's 0.8. So I go to a maximum and I count down 0.8. I go to a minimum and I count up 0.8. Where are they meeting at? The x-axis, which is the line what? Y equals 0. Luckily, calculators aren't like phones. There's like 2 or 3 that dropped class. You guys all have smashed screens. You need like 800 otter boxes on your calculators. Like otter box, like a double otter box. Like those were otter boxes before otter boxes were made. So I think they should have fashioned otter boxes around the TI-84 calculator. Maybe that's what they did. They're heavy duty. Those things hit the floor. It's a rarity. The only thing that really breaks them, and I'm going to tell this to you, is if you leave them in your car in -30 and then bring them in and try and use them. It sometimes destroys the screen. You turn black and you can't get it back. Yeah. All right. Okay. Well, you've made it through winter season, so you're good now. All right. The amplitude is 4. Do you see that? So we're going to go to our maximum. We're going to count down 4. So this is 2, 4, because each of these is worth 2. Then 4 again. 2, 4. Where are we meeting at? Y equals 0, yeah. The next one is 5. So we start at our maximum, count down 5. Start at a minimum, count up 5. Where does this one meet again? Y equals 0, because these ones have been symmetrical about the x-axis, right? Okay, this one has an amplitude of 6. So I count down 6. It has a minimum at -6. That's going to come along here. Count up 6. And I'm going to meet at, once again, y equals 0. Then we're going to flip over. All right. This one, amplitude of 3. So we're going to count down 3s. 1, 2, 3. Oh, it's meeting at -1. Hopefully this one comes the other way. Meets a -1 too. 1, 2, 3. Which is the line that they're meeting at? 0? Y equals -1. And you need y equals or it's not a line, correct? It's a number, -1. Hello, we're back. So, 9, if they don't watch the podcast. 9, let's count. So 3. 1, 2, 3. Count up 3. 1, 2, 3. And where are we meeting at? Y equals 4. Okay, this one has 5. So this is 15 here. So I count down 5, count up 5, and I'm at y equals what? 15. And then number 11, it's 6. So I count down 6. 1, 2, 3, 4, 5, 6. Then I count up 6 from the minimum. 1, 2, 3, 4, 5, 6. And we're meeting at y equals what? 3. Did you know that we just found every midline? Yep. Midlines are the lines that cut the graph in half. So we're going to go to these notes. Midline is the line, and we'll say horizontal, that cuts the graph in half. So we can find it by where the amplitudes meet. We can do it that way. Or there is a formula. Now, I'm trying to find half the distance. Everyone paying attention? I'm trying to find the half point between the max and the min, right? The half point is a fancy way of saying average, correct? So that middle line is just the average between the highest and the lowest, yes? How do I find the average of two test scores? What would you do? Add them up and divide by 2. So if I want the average between the maximum and minimum, what am I going to do? Add them up and divide by 2. So people get these formulas mixed up. You can't. So if you're going to use the formulas, you need to know them correctly. Amplitude is max minus min, absolute value divided by 2. And then your midline is just literally your average. It's the average of something. The average of the max and the min. So how do we find the average of the max and the min? Well, the midline, the formula for it is this. It is a midline. Do you see how it says line on it? A line has to have a variable, so x or y. All of these have what? Y, because they're horizontal, correct? So the midline formula is y equals the max plus the min, I'm taking the average of the two, divided by 2. What happens if you mix up the midline and the amplitude? What's going to happen on a test? Bad things. It's just not, you're not going to pick it. Do you think they'll have the midline and max and, or sorry, the midline and the amplitude as an oopsie for the common error? Yeah, they will, sadly. Okay, we agree? So, let's go back and test out our, we already found the midlines of every single one. We drew them, right? So let's test it out with our actual formula. So here we say the midline's y equals 0. Well, let's test it out. The midline doesn't equal. The midline is y equals. Please make sure you have y equals. Yeah. It's y equals. Then we're doing the max plus the min. So it's going to be 3 plus negative 3 divided by 2. So it's the same numbers as amplitude, but we have a plus sign between them. So it's 0 divided by 2. So it is 0. Y equals 0. That's the midline. If they ask you for the median value is just a value. It's just a midline value. So what would the median value be? Just 0. That's the difference. So midline is a line. Y equals. Median value is just a number. It's just a value. Midline needs a variable. Okay, let's try the midline for this one. The midline is the average of the max and min. So we're going to go maximum, which is 6, plus minimum, which is negative 2, divided by 2, which is 4 divided by 2. Sorry, it shouldn't be midline equals. I just set this and then did it. Your midline, y equals. So y equals 2. And then what's my median value? 2. You see the difference? One is y equals and the other one is just the value. All right. This one. My midline is y equals the maximum, which is 3, plus the minimum, which is negative 3, divided by 2, which is 0 over 2, which is 0. So my midline is y equals 0, and my median value equals 0. We agree? Okay, what do you think I'm going to make you do? Do it for all of them. Go. We have our midline at y equals 0, and our median value at at 0. Now how do I know that? Because I've already found them, right? We can use the formula to find them, yes, but did we not just find them before we even used the formula? By counting our amplitude up and our amplitude down, right? Amplitude down, amplitude up. I said it opposite, but yeah. All right. This one has a midline. And make sure, check yourself, check every single one you've done. Does it say midline y equals? Because if not, if I ever have a y equals, you're getting no marks. Because it's not a line, it's just a number. It's like 7, 2, 0, right? It's not a line. So everyone check your work. Y equals 0. Why am I so harsh about it? Because I want you to get marks. I know, mean. Oh, I know. That's okay. I'm not mean. I just want full marks, right? I want full marks for you to get full marks for you, okay? Because your mark, you guys leave with it, and then I just stay here. So I want you to do what's best for you, okay? This one, again, it's symmetrical about the x-axis, so I have a midline, check your work, at y equals 0 and a median value that equals 0. This one is a midline at y equals 0 and a median value equal to 0. This one we have a midline at y equals -1 and a median value equal to -1. This one we have a midline at y equals 4 and a median value equal to 4. Then here we have a midline of y equals 15 and a median value to 15. Then here we have a midline at y equals 3 or a median value. Okay, guys, the next thing we're doing is period. There is no set formula for it. You have to understand it. So everyone put down your pencils. Everyone puts down their pencils. Every single person. Okay? We're just going to watch. Ready? Okay. I told you that a pendulum can represent a sinusoidal graph because a pendulum would be from a max to a min, back to a max, back to a min, back to a max, back to a min, back to a max, back to a min for the same amount of time, correct? So it'd be like at a max, then a min, then a max, then a min, then a max, then a min. We agree? But it has to be the same amount of time that it takes to go. It has to be a perfect pendulum. It can't be like woo woo and then woo woo and then woo woo. Like it doesn't make a sinusoidal, right? It has to be the exact same, like almost like with a metronome, you know? Do 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 exactly. Okay. Now the period of a graph is how long it takes to go from a max to a max or a min to a min or from the same spot to the same spot. So let's pay attention. If instead I had a circle, so here's my circle. A circle still has a min and a max at the same rate, correct? So you would still be going, if I started here, then went around to here, I would still be going max to min, to max, to min, to max, to min, and it would keep going. We agree? A period is how long it takes to, from the same height to get back to that height in one revolution. Okay? So if I started, say I started here. That's my height, correct? So I would be starting like here. Same height, right? Now I want to know how long it takes till I get back to that height and then going, say I'm going this way. So I'm going down to my minimum. Do you see that? Down to my minimum. See how I'm matching it? Then up to my maximum, up to my maximum. Yeah. Then back to that same spot. You see how I just did that? Start at the same height. Went past the minimum, back up to a maximum, back to that same spot. What's going to happen after that? I'm going to do another revolution of that circle, correct? Then what's going to happen after that? Another revolution of that circle. We agree? Yes? Okay. So if I start here, I have to get back to that spot. If I start at the minimum, what do I have to get back to? The minimum. We agree? If I start at a maximum, what do I have to get back to? The maximum. What if I go from maximum to minimum? What would that be of the period? Half. Max to min would be half, or min to max would be half. Do we agree? Because it would be half the distance till I got back. Does that make sense? Okay, so let's go back to our notes section. Right here. Went to the period. So for the period, it's how long, so the time it takes to do one revolution horizontally. Right? How long for the time it takes to do one revolution horizontally. So that could be from a max to a max. Or a min to a min. Right? Or what if I went from a max to a min? What would I have to do? I'd have to find that from max to a min and then do what? Times it by 2. Right? Or a min to a max and times it by 2. Or I could just go from any height back to that same height, but I have to pass through a max or a min. Right? So like, those are all good if it's max to max and min to min. But what if my graph looks like this? Say that. Say I started here. Well, I would have to go till I repeat myself again, right? So I go past a max. Have I repeated myself yet? Past a min. Then I get to here, and then that's that full circle, correct? So I would need to know this. Say this was 30. It'd be from 0 to 30. So that's a distance of 30. Time of 30. Does that make sense? Do we agree? Then after that, it would do another full circle. Another full circle. Another full circle. Do we agree? Okay, so let's go back to number 1. This one is by far the hardest for people to understand. Okay. We can go from a max to a max or min to min. Those are faster, but sometimes the maxes and mins aren't on nice values. So I will always try personally myself. I will start at the y-axis and then go till I repeat myself. Because if I start at the y-axis, it's just the horizontal distance from 0 to wherever I get to. And that's really easy to figure out what that number is. Okay? So let's count it. So I'm starting at the y-axis, and I'm going to go to a maximum and then back down to here. Have I repeated myself yet? Have I even reached a minimum yet? No. I know I'm not done until I've actually saw a max and a min. We agree? So I start at this height, I go past a maximum, then back down to a minimum, and then I have to go back to that height again. We agree? So horizontally, that's from 0 to what they say is pi. So how far is it from 0 to pi? Not a trick question. Pi. That's it. So the period equals pi. Do we agree? All right. So let's go to this one. I'm going to start on my y-axis. Why is the y-axis so nice this time? What's on the y-axis? A minimum. So where do I just need to go to? A minimum again. That's it. When the min or the max is on the y-axis, that's the easiest. So I go from a min, then I go up. Come on, I had a highlighter. Then I go up to a maximum, then I go back down to a minimum, and then what's going to happen after that? What's it going to do? do a whole nother rotation, right? This was a minimum. So basically I started at a minimum, then went back to a maximum, then back to, let's pretend I started at minimum. Minimum, went up to the maximum, then back down to the minimum, which is a circle, correct? So what horizontal distance is that? 0 to 6. So what's the period? Equals 6. Oops. So for this one, I'm starting here. I'm going past, come on, wait, stop it. This is my highlighter. See, it works here. All right. I'm going past the max back to this height. Then I would have to go a minimum back to that height. Right? So how far is it from here to here? 6. How far is it from here to here? Another 6. So what's the period? What's 6 plus 6? 12. Okay, then we're going to flip over. Okay, so I'm going to start on my y-axis. On my y-axis, and I'm going to go past the max, past the min, back to that height. Do you agree? So how far is that? To here it says it's 6.28. So from here to here it's 6.28. So from here to here, what's it going to be? Another 6.28, right? So I go 6.28 times 2. What's this one going to be? 12.56. So that's the period. Try the rest. So this one, we start at the y. You hate me. Okay, we start at the y. We go past the max, back to this spot. Haven't gone past the min yet. Have to go past the min, then back to that spot. If remember this, guys, if you're on a circle, we're starting here technically, right? That's where we're starting. If we go past a max back to here, have we done the circle yet? No, so we still have to go past a min back to that height. So unless your y-axis starts on a max or starts on a min, you have to go past a max and a min back to the height. Does that make sense? So unless it starts at a max or a min, you have to start at that height, past a min or a max, past a max or a min, and back to that height. Does that make sense? Ish? Okay. We'll go with it. Okay, so it's 0 to 4 pi, so the period is 4 pi. Okay, this one. Are we starting at a max or a min? Are we starting at a max or a min? Have we started at a max or a min? Here's the max, here's the min. Are we starting at a max or a min? No. Is this the absolute highest or lowest this graph goes? No. So if it's not the absolute highest or lowest it goes, I have to go past the max min till I go that height again, right? Do you know what I'm saying? So I'm going to go past a max. Come on, board. Past a max, past a min, then back to that height. So the period is 12. So unless I'm starting at a max or a min on that y-axis, I have to go past a max min. Okay, I'm starting here. Am I starting on a maximum or a minimum? No. Here's the max, it's higher. Here's the min, it's lower. So I'm not starting at a max or a min. So I have to go past a max or a min, correct? So I go past the max in here, go past the min, and then I'm going to have to go back up. How the heck do I figure out what that is? Yeah, so from here to here is pi over 2. Then this is going to be another pi over 2. So the period equals pi over 2 times 2 over 1, technically. The 2's cancel. My answer is pi. Okay, now we're flipping over. Okay, for this one, I'm going to start on the y-axis. Am I starting at a max or a min? Am I starting at a max or a min? No, so I have to go past the min. Then am I done when I get to here? No, I still have to go past a max, and then I can stop once I get there. You know what I'm saying? Does that make more sense? Okay, so that takes me pi. So the period equals pi. All right, then we're going to go to this one. Starting on the y-axis. Here I am. Am I at a max or a min? No. So I have to go past the maximum back to that height. Am I done? Or I still have to go past a minimum, and then I stop when I get back to that height, correct? So this is 2 pi to get me here, and another 2 pi to get me here. So what's this going to be? 4 pi. Because it's 2 pi times 2. We agree? All right, here. Am I starting at a max or min? This is the highest I go? No. It's the lowest I go? No. So I get to here, then I still have to go past another min and back up. So how far is it to get me to here? 12. And then to here? 24. There's 12 and 12. So the period is 24. And then this one's hard. Hardest you could get. So basically, we can go from here to here. And what we know is every 4 is how many? Pi. We agree? Every 4 blocks is pi. So let's count how many blocks this is. 1, 2, 3, 4, 5, 6, 7, 8. So how much is that? Every 4 blocks is pi. So this is 1 pi. And then this is 2 pi. So I know from a min to a max is 2 pi. Do you agree with that? And is a min to a max a period? A min to a max is half a period, because it's a min to a max. Have I done a full circle? No, I need to go back down again, correct? So what's the period of this one then? 2 pi, what? Times 2. So 4 pi. Tomorrow we're doing equations, and then on Wednesday we have to just do the actual equations. We're actually done the unit. That's how fast it is. So we will be done it this week.